the equation of a straight line passing through these 2 points, 3,7 and 6,13. Hello, my name's Paul, and I've been asked to do a few videos on, well, pre-calculus. I'm calling these videos Bridging the Gap from equations of straight lines to integral calculus. And I'm going to be showing you a lot of new terminology and explaining what that terminology means. The hope of doing this is to take all the mystery out of calculus and to make people think that, hey, this is nowhere near as difficult as it looks. Okay, so let's get stuck into a very simple question that hopefully most people know how to do. So we're looking at the equation of a straight line, which we know is y equals mx plus c, where m is the slope of the line and c is the y-intercept. Let's just draw a quick, or sketch a quick graph. Doesn't have to be nice, which is a good thing because my writing is terrible. Okay, so here's our line. And so the slope of the curve is how much it goes up by how much it goes across. Can I draw or can I draw? Okay. Right, so how much it goes up, you might have heard it called the rise. You can think of a set of stairs. And the up part of the stairs is called the rise, and the across part of the stairs is called the run. And so how much it goes across the x-axis is called the run, and how much it goes up the y-axis is called the rise. Okay, let's work through the example and then I'll introduce you to some new terminology. I was in two minds as to when to introduce you to the new terminology, but I'll do it in a bit. First, let's just remind ourselves how to do this question. Okay, so the rise is how much the y-axis has changed, or how much the length up of the slope has changed. So it's gone from 7 to 13. So the rise is 13 minus 7. And the run, well, it's gone from 3 to 6. So the run is 6 minus 3. 13 minus 7 is 6. 6 minus 3 is 3. So our rise divided by our run, which is our slope, is 6 divided by 3, which is 2. And that's our slope, which is m. Now our y-intercept, that's the point where x equals 0. That's where we intersect the y-axis. So we're calling that c. So let's write this equation out. Y equals 2x, because we know the slope is 2 now, plus c. How are we going to find this c? Well, we can plug any of these values in. I'm going to choose 6 and 13. So 13 is equal to 2 times 6 plus c. Please excuse my atrocious handwriting. Okay, well 2 times 6 is 12. So 13 is equal to 12 plus c. Should be obvious now, c is 1, but we'll go through the motions. 13 minus 12 is equal to C, 1 is equal to C, and by the principle of equivalence, C is equal to 1. Okay, so we've got our equation as y equals 2x plus 1. Nice and straightforward. Hopefully that wasn't new to anybody. Now for the new terminology. I'm going to do this exact same thing again, but this time I'm going to use a slightly new terminology. Alright, so we've got our graph. And we've got our straight line. And this time, instead of saying rise over run, even though it means exactly the same thing, and look at me, I drew it wrong again. Instead of saying rise over run, I want to say delta y by delta x. What the heck is that all about? Okay, so this triangle is the capital Greek letter D, or delta, and it means change in. So all I'm saying is that the slope is the change in y divided by the change in x. And I want to make it clear that this delta is not a variable. It doesn't cancel out. So we cannot say cancel, it's just y over x. We can't say that because delta y is not some variable multiplied by y. It's change in y divided by change in x. This is no different from saying rise over run, so think of it that way if that helps. But this is just an introduction to some new terminology. And we could do the same calculations exactly the same. So 13 minus 7 equals 6 divided by 6 minus 3 equals 3, and 6 divided by 3 equals 2, y equals 2x plus c. Plug the numbers in and we get c equals 1, exactly the same. So all I want to do is use this new terminology from now on. Delta y by delta x. And I'm going to run through a couple of examples just to get used to using this new terminology. Okay, so we're asked to find the equation of a straight line passing through these 2 points, 2, 11 and 3, 18. This time we can dispense with the graphs. So we've got delta y, or change in y, is equal to, alright, so these are our x and y coordinates. Let me just draw this in here. X comma y equals, right, so these are our y's. So we've got 18 minus 11, and then we're dividing by change in x. So we're dividing by, and it's gone from 2 to 3, so that's 3 minus 2. Right, so 18 minus 11 is 7, and that's divided by 3 minus 2, which is 1. So our slope, which is m, is equal to 7. Okay, so y equals 7x plus c. So let's pick this one now. So when x equals 2, y equals 11. So 11 equals 7 times 2 plus c. So 11 is equal to 14 plus c. Well, 14 is bigger than 11, so we know c is going to be negative. 11 minus 14 equals c. So negative 3 is equal to c. So y is equal to 7x minus 3. And that's our answer. And let's just do one more so that we're comfortable. Okay, so this time we're asked to find the equation for the straight line passing through the points 2, 4 and 4, 3. Okay, so our slope is equal to change in y over change in x, which is equal to 3 minus 4 divided by 4 minus 2. Which is equal to 3 minus 4 is negative 1 and 4 minus 2 is 2. So that's negative 1/2. And we can plug either of them in. Well, we did this one last time, so let's do this one this time. So 3 is equal to minus 1/2 multiplied by the x value is 4 plus a constant. We don't know what the constant is yet. So 3 is equal to minus 1/2 times 4. Well, 4 divided by 2 is 2, and then multiplied by negative 1 is negative 2. And then we add c. Bring the 2 over. It's going to change sign. So 3 plus 2, my plus is horrible, equals 5. So y equals negative 1/2 x plus 5. We can rearrange that in any way that suits us, but this is in slope intercept form, which is the way we want it. Okay, I hope that was helpful, and I will look forward to seeing you in the next lesson.